Hi, sixth graders. We're on our Unit 3A lessons. This is our rational numbers unit. So let's label our page with prime factorization. That's the unit for, or lesson for this video. Being able to identify numbers as prime or composite, using prime factorization, and expressing a whole number as a product of prime factors. So before we talk about prime factorization, let's review factors and multiples. So remember, factors are numbers that are multiplied together to get a number or to get a product. Multiples, you start at a certain number and count on. So if we look at the number 12, the factors of 12, so the factors are, remember, two numbers multiplied together to get that number. So if we're going to list them out, we always start with 1 and the number, because we know 1 times 12 is 12. I know 2 times 6 is 12. And I know 3 times 4 is 12. Notice how I write them in order. And then I know once I get to the middle, like 3 and 4, I know that there's no more in between because I have all of my pairs. Multiples, on the other hand, of 12 would be 12, 24, 36, 48, 60, 72, and so forth. So very important that we remember the difference between factors and multiples. All right, prime and composite numbers. So we've already talked about prime and composite numbers a few units back. Remember, a prime number is a whole number greater than 1 that has only 2 factors. So 1 in itself, meaning there's no other numbers that can be multiplied together to get that number. And then a composite number does have factors besides 1 in itself. Remember, 0 and 1 are not prime or composite, so they are neither. And also remember, 2 is the only even prime number. So 2, remember, is prime. All right, determine whether each number is prime or composite. So I know 17, the only factors are 1 and 17. Nothing else multiplied together is 17, so that's going to be prime. 12, we just talked about the factors on the last page. We know that there's more than 2 factors, so that's going to be composite. 11, we know, is prime because the only numbers multiplied together are 1 and 11. 15 is composite, even though it's odd. We know that it has 3 and 5 multiplied together. And then 24 is even, so right away we know that's composite. So prime factorization is, this would be a good word to write down. You don't need to write this whole definition, but it's every composite number can be written as a product of prime numbers. So we know that 24 can be written as a product of like 2 times 12 or 4 times 6, but these are not prime numbers. Instead, we can factor all of them out so that we can have products of only prime numbers to get to our number. So there's a couple different ways that we can do that. So let's look at 24. And I would probably write both of these methods down in your notebook. So first we can use a factor tree. So we would start with 24. And I can think of any 2 factors of 24, meaning 2 numbers multiplied together to get 24. So I'm going to start with 4 and 6. You could start with 2 and 12, you could start with 3 and 8, but I'm just going to start with 4 and 6. I ask myself, are either of these numbers prime? None of them are, so then I keep going. So 4, now I think of 2 factors of 4, which would just be 2 and 2. And I ask myself, are any of those prime? 2 is prime, so I circle it. 2 is prime, so I circle it. And then I go to 6, and I know it's 2 times 3. 2 is prime, 3 is prime. Once they're all circled, then I know that I'm done. And then I have to write it out as a product of prime numbers. So I start with my lowest number, which is 2, but I have 3 of them. So 2 times 2 times 2 times 3. And then I can write it as 2 to the third power, because 2 times 2 times 2 is the same as 2 cubed times 3. So that would be my product of primes. This would be okay, and this would be okay to write it like that. Dividing it by prime numbers, so I can start with 24. I think of a prime number that it can be divided by, which 3 is prime, so let's divide it by 3. 24 divided by 3 is 8, so I'm going to write it like this. 8 is not prime, so now I can think of a number, a prime number, that it can be divided by. So I know that it can be divided by 2, which gives me 4. Again, 4 is not prime, so then I know I have to keep going. 4 can be divided by 2, which is prime. And then I get 2, and then 2 is prime. So now I know I stop. So then I know my product of prime factors is going to be all the numbers that I divided by. So I'm going to rewrite that out. 2 times 2 times 2 times 3, which again is 2 cubed times 3. Okay, I want you to pause me and do 18, 28, and 16. I want you to use both methods, like maybe use method 1 for 18, method 2 for 28, and then whichever method you want for 16. And then unpause and check. So I put it on this page so that I would have more room. So we'll start with method 1, for 18. So I know 18 can be divided by 3 times 6 equals 18. 3 is prime, so I stop there. And then 6 can be divided by 2 and 3. And then those are both prime, so I stop there. So it's 2 times 3 times 3. And the reason why you want to circle them is so that you don't miss them, because sometimes all of a sudden you'll have lots of these branches and it will get really small and tight. So the circles help them all stand out. So then I can rewrite this as 2 times 3 squared. 28, if I use method 2, dividing by prime numbers, I know that it can be divided by 7, which is a prime number, and then I get 4, which is not a prime number. Divide that by 2. 4 divided by 2 is 2, which is prime. So then I know that my product of primes is going to be 2 times 2 times 7, which is 2 squared times 7. And one way to check, which I should have mentioned previously, is that if I multiply these out, like right here, if I multiply this out, it should equal the number I started with. So I know 2 times 2 is 4 times 7, and I get 28. If I go back here, I know that 2 times 3 is 6 times 3, and I get 18. So that's my way to check. Okay, and last one, 16. If I do the factor tree again, 16 I can do 4 times 4, and then those each can be factored into 2 and 2. And I'll circle each of those. So then I have 2 times 2 times 2 times 2, which is 2 to the 4th power, which does equal 16. So then it works out. And then lastly, sometimes we have an algebraic expression. Remember, an algebraic expression has a number, a variable, at least one variable, and at least one operation. So if we have 6ab, which is the same as 6 times a times b. So I'm going to factor out my 6, which is 2 and 3, and those are both prime. My a's and my b can't be factored out anymore. So my prime factorization of 6ab is going to be 2 times 3 times a times b. and I actually separate my a and b with the multiplication sign. And then 18xy. So again, we have 18 times x times y. So 18, 3 and 6, and then 2 and 3. So that's prime, that's prime, that's prime. So my prime factorization is going to be 2 times 3 squared times x times y. For an instance where we would have to factor out the variable, so if we have, let's say we have 16, we'll use that again, x squared y squared, I would refactor out my 16. So 2, we'll do 2 and 8 this time. So 2, and then 2 and 4. So 2, and then 4 is 2 and 2. So, and then x squared, I know is the same as x times x. And y squared is the same as y times y. So my factors of x squared are x and x, because x times x equals x squared. So then my prime factorization of 16x squared y squared is going to be 2 to the 4th, because I have 2 4 times right here, times x times y times y. Or if we didn't leave it as x squared or y, we could actually write it as 2 times 2 times 2 times 2 times x, times y times y. All right, so there you go on prime factorization. Review your notes. Make sure you have good notes with your page labeled and the definitions in your notebook. I will see you in class.